Well, okay, and we're back. So today we're going to present kind of the big picture of the next section of the course. So what have we done so far? We've talked about descriptive statistics, right? How do we describe a set of data? Mean, standard deviation, median, range. We've done a little normal distribution, percent above, percent below, percent between. We've done some probability, complicated probability. We've talked about continuous and discrete random variables. And now we move into really the next part of the course. And this is where we're going to spend the next few months, really. And it's amazing because we're going to spend a lot of time talking about just a couple of topics. So, inferential statistics. What the heck does that mean? So you got descriptive statistics and inferential statistics. Well, think about it. AP English kids, Latin kids, inferential, inference, infer, right? So what do you do when you infer something? You take a statement and you make a broader conclusion, right? You infer something. And that's exactly what this is. And I'll tell you, for the next 3 months, this is what you're going to do. Use a sample to make conclusions about a population. That's it. You're going to use a sample to make conclusions about a population. Now, as you can probably guess, it gets a little complicated. And so what we're going to do today is I just want to introduce to you the main things that you're going to be working with for the next foreseeable future. Okay? So here we go. All right. We've got capital N. Capital N is your population. Now, we don't really ever know what that number is. Capital N might be something like all people over the age of 60, or all teenagers, all college students, right? So N represents the population. Well, if I want to know how much beer college students drink, am I going to survey every single college student? No, all right, that doesn't make sense. What I'm going to do is I'm going to use a sample, N, small n. Now, these are the variables that we're going to use. These are the statistically acceptable variables, right? Any statistics class, you're going to use these numbers. You're going to hear about an SRS, which is a simple random sample. Going back to my beer in college question, if I want to find out how much beer college students drink, am I just going to interview the members of the Alpha, Beta, Delta fraternity? No, that would be a biased sample, right? I've got to try to find a simple random sample of college students. And that's what you pay J.D. Power, Gallup. That's what there's a lot of thinking that goes into how to create a simple random sample. You might say that a simple random sample is kind of complicated. Get it? Simple, complicated. All right. N is our sample. Here's the great thing about this course, Introductory Statistics. You're only going to study 2 things, means and proportions. And this is going to be your life. And the next 4 chapters in this textbook and in most textbooks break down proportions first, then means. Proportions, means. And they're broken down. If you look ahead, each chapter, the first half is proportions, the second half is means. Why those 2? Well, I'll answer that question in just a second. We have mu which is the population mean, right? What is the average height of 18-year-old girls? Well, again, I don't know the exact average height because I'm not going to measure every single 18-year-old girl. I'm going to use a sample, and when I do that, I'm going to get the sample mean. So understand the difference between mu and x bar. And understand the difference again between the word population and the word sample. Population mean, we call this a parameter. And we call the x bar the statistic. So the parameter goes with the population. Again, we don't really ever know that. There may be some contrived examples early in the text where we do, but we don't really ever know that. We do know the statistics. We do measure this, okay? And then if I can go down here at the bottom, we have P, the population proportion. Again, why proportions? Well, if you think about it, what kind of questions do we measure? How many people voted for candidate X? That's a proportion, right? What percentage of people put chocolate milk on their cereal? That's a proportion. And if you think about it for a second, most things that we measure are either proportions or means, aren't they? Right? What percentage of undergraduates scored above 1200 on the SAT? A proportion problem. What's your average SAT in your incoming class? A mean problem. Okay, this of course again is the parameter. What do we measure with our sample? P hat. So you're going to hear a lot about P hat. That's your sample proportion. Now I'm running out of ink here. Okay, this is our sample proportion. And again, parameter, statistic. All right, and we call the way we write P hat is it's P with a little caret over the top of it. That same little button you use for the exponent on your calculator. What else are we going to have? We're going to have some standard deviations. Okay, so you might see some notations there. The standard deviation, sigma, and S sub x. This is the standard deviation for the population. We estimate that with the standard deviation for the sample. You might have noticed that when you do one variable stats on your calculator, you get a sigma and an S. Okay, so this is basically your life. All right? You're going to be studying means and proportions. You're going to try to make a conclusion about a population from a sample N. And what we're going to do for the next few months is talk about 1, how to get N, 2, how big N is, 3, what the results of N tell us, right? And of course, can you guess how we're going to do that? Calculate a standard deviation? Check. Maybe use a normal curve? Check. And then use something called a T distribution, which is very similar to the normal curve. Check. So these are all things that we're going to be doing with the inferential statistics. All right, and this is kind of your life. All right. For example, let's take a look at this problem. Okay, now again, I want you to write this down because And this will be kind of the last big thing that I want you to write down. But this is important, okay? Let's see if we can identify, first of all, is this a proportion question or a mean question? And let's identify the variables. Okay. Gallup poll asked a random sample of 515 adults if they believe in ghosts. 160 said yes. So you can pause the video and write this down and then come back to it. Okay, and we're back. First of all, proportion or mean? 160 did something out of 515. This is a proportions problem. So step one, identify as a proportion or a mean. It's a proportion problem. Let's identify the big N. Now, do we know the numerical value for N? No, we don't. But what is it? All adults. What's our sample? Our sample is 515. Okay, so what happened? In a proportion problem, we often call X, which is the desired outcome here. Okay, so the desired outcome is 160 believe in ghosts. Okay, so my P then becomes the proportion of all adults who believe in ghosts. I don't know what that is because I do not have a magical phone that can call every adult. So what are we going to do? We're going to take a sample and we're going to get a P hat, which would be 160 out of 515. So P hat is our sample proportion, okay? This is our estimate. And this is approximately equal to 0.31. Okay. Now, the question for the foreseeable future. How well does 0.31 estimate P? Well, if I could answer that today, then you'd all want your money back. But this is what we get to spend the next 2 months answering. How well does 0.31, or in this case, P hat, 0.31, estimate the actual P? This is what we do. In chapter 8, we do a confidence interval. In chapter 9, we do a test. Okay, but that's what this is all about. So the point of today then is just to introduce you to these concepts and to these words. All right? And so as you begin your study of inferential statistics, just keep in the back of your mind what we're doing. We are taking a sample, measuring the sample, either the mean or the proportion, right? How tall are my 30 teenagers, and or what percentage of my 30 teenagers put chocolate milk on their cereal? One's a mean, one's a proportion. We then are going to learn how to apply some calculations to the results of that sample so that we can infer something about the population. Keep reading, start practicing problems, and good luck.